Hello, and welcome back to my YouTube channel. My name is Professor Govala, and today I'm going to be doing an example on the Fourier transform, specifically the Fourier transform of a rectangular function, where we take the general rectangular function where my signal in the time domain is a rect t minus t naught over capital T, where my t ranges from this t naught minus t over 2 to t naught plus t over 2 and is 0 otherwise. Again, we're tasked with finding the Fourier transform x of omega, where a, t, and t naught are real constants. Like my previous example videos, I encourage the viewer to pause the video and see if they can solve the example, and then come back to the video and see if they received the correct answer. So in terms of the solution to this problem, from our previous video, we know that the Fourier transform capital X of omega is equated to the integral from negative infinity to infinity of x of t times e to the minus j omega t dt, where again in our case, we get that this is the integral from negative infinity to infinity a rect t minus t naught over capital T e to the minus j omega t dt. So then now if I consider that this function here, my x of t function, is equated to a for only a specific range, I can say that my capital X of omega is equated to my integral from t naught minus t over 2 to t naught plus t over 2, because that's the only range I care about, times this constant a times e to the minus j omega t dt. And then if I take the integral of this function, I get a e to the minus j omega t times negative 1 over j omega, where my parameters are going to be t naught minus t over 2 to t naught plus t over 2. If I then go ahead and plug in my conditions in for t, I get that my Fourier transform x of omega is equated to minus a over j omega times e to the minus j omega times t naught plus t over 2 minus e to the minus j omega times t naught minus t over 2. If I go ahead and then distribute this negative signal into my parentheses, I get that this is equated to a over j omega times e to the minus j omega t naught minus t over 2 minus e to the minus j omega t naught plus t over 2. So then if I pull out the individual exponential terms, I get that this is equated to a over j omega times e to the minus j omega t naught times e to the j omega t over 2 minus e to the minus j omega t naught times e to the minus j omega t over 2, where in this case I can pull out an e to the minus j omega t naught. So if I go ahead and do that, I can equate this to a over j omega e to the minus j omega t naught is what I'm pulling out, and this is times e to the j omega t over 2 minus e to the minus j omega t over 2. And something that we want to note is that sine of omega is equated to e j omega minus e minus j omega over 2j. So what we can say is that 2j sine of omega is equals to e j omega minus e to the minus j omega. If we consider that this term here, omega times t over 2, is my omega, I can say then that this here is this 2j sine of omega t over 2. And I can go ahead and multiply it by a over j omega times e to the minus j omega t naught. Again, this is equated to my Fourier transform, capital X of omega. So as you can see here on the numerator and the denominator, I can cancel out these j's. And then I'm left with x of omega is equated to 2a over omega times e to the minus j omega t naught times sine of omega t over 2. And essentially this here can be your solution, but let's go ahead and write it in a more formal manner using the sinc term, which you will find in most textbooks, and then formally write it in terms of mapping the time domain x of t to the frequency domain x of omega. Okay, so the first thing I'm going to do here is I'm going to multiply both numerator and denominator by this capital T. So then x of omega is going to be equated to 2a capital T over omega t e to the minus j omega t naught sine of omega t over 2. And what I'm going to do is I'm going to write this on the denominator. So then this becomes a t e to the minus j omega t naught sine of omega t over 2 divided by omega t over 2. And I'm going to use some knowledge on sines. So I know that sine of theta over theta is equals to this sinc function of theta. So therefore, my Fourier transform x of omega is equated to this a t e to the minus j omega t naught times sinc of omega t over 2. And to write it more clearly, we can say that therefore, for x of t is equals to a rect t minus t naught over capital T, the continued time Fourier transform is going to be a t e to the minus j omega t naught times sinc omega t over 2. And again, this is equals to capital X of omega. And for most standard textbooks, they consider a case where for a is equals to 1, t is equals to 1, and t naught is equals to 0. We can say that x of t is going to be basically this rect of t has a continuous time Fourier transform of simply the sinc of omega over 2 function, which again is this capital X of omega. Okay, if you have any questions or concerns, please leave them down in the comment section below, and I'll be sure to get back to you. If you liked the video, please give it a thumbs up, and please share the videos to your colleagues and friends so they can also obtain the knowledge given in the video. And if you like what the YouTube channel is providing, please consider subscribing. It really helps the algorithm. Thank you.